Hello and welcome back to my workbench. It is time once again to fix something. Today on the workbench we have a PS5 Slim, digital edition obviously. And this one is, I believe, a no power. If I can read the description of what the seller said. Has no power, tried a new power supply, but that did not fix the issue. So that's all we know at this point. So let's see if we can give it some AC power and see. Yeah, I think I saw that power supply start up. So I think the power supply is running, which is what they said in the listing. But no signs of life. No beeps, no lights. Yep, that's where we are. Okay. All right, well, let's get the covers off and see if we can figure out why it's not beeping or giving us lights or whatever. Well, I'm in the process of removing this circuit board, and I have noticed something, and I wanted to share with you, and it could be important. Notice anything odd about this ribbon connector? Yeah, it's not connected. And of course, your power button and your lights are all through that ribbon connector. So, yeah. So let me get this hooked up, and let's do another test. Let's see if we are getting an attempt to turn on. Give me just a moment. I need some hands for this. All right, with the ribbon connector plugged in where it should be, I've already got AC power applied. What does it do now? Oh, still nothing. Okay. I had such high hopes for that. No. Nope. No beeps, nothing. Okay, let me continue getting this board out. All right, then this main board is out, and I'm ready to apply some power to it. I want to see what kind of current draw we get. We did have a nice dry spot, if I can show you, on the EPU. So, which is surprising considering how new this board is. I mean, this should be a relatively new PS5, but anyway, the liquid metal has run away. So I'm going to give it 12 volts. I'm going to see how much current draw we get. That's dead, 3 milliamps. That's very, very dead. Very dead. Okay. So, do we have 5 volts? All right, let's get set up and let's do some troubleshooting. All right, so we have an EDM044 board, which I'm not terribly familiar with, the layout of it. Let's just look for some landmarks. Here's our south bridge. And right there nearby, is that the power supply for the south bridge, or is it on this side? No, I believe it's going to be the other side. Right in here. Should be that RT5126 or dialogue chip. Let's just see what we have going on. Find me a ground. I'm going to give it 12 volts. As you can see, we do have 12 volts. All right. What do we have around this area? 0. I'm looking around this chip right here, seeing a whole lot of nothing. This is, let me check under the microscope what chip they used on this particular board. Dialogue DA9065. So this is the dialogue version, which is equivalent to the RT5126, and I'm not getting much of anything coming out. And I'm looking for 5 volts coming into this thing, and I'm not seeing it. Should be a fuse connecting it. Where is our 5 volt supply on this model? Have not worked on a lot of Slims, but it's coming. Right, there's 12. We know we have 12. We don't have much else, though. What is this? 12 volts. Just look for the large coils, and that will lead you to the switching supplies. Yeah, that looks like a 12 volt rail. I'm just looking at these large coils. This is going to be the one for the RAM, the 1.35 into the RAM, which is not active yet. This looks like a standby supply for the Wi-Fi Bluetooth module. Probably, I'm not sure on this model if it's 1.8 or 3.3, but it's a single supply on this model. Ooh, there's 5 volts. We do have 5 volts, at least going into this converter, which is outputting, what's it outputting? No, that's 5 volts in. Where's the output? What do you supply? I'm pretty sure just by its location that is for the Wi-Fi Bluetooth module. What do we have over here? We don't have any voltage into the Wi-Fi Bluetooth module. That's interesting. Which on previous models was a separate supply, and that does look like a separate supply for the Wi-Fi Bluetooth module. But it is getting 5 volts, but does not appear to be enabled to run. So it needs something, some other voltage. Maybe it's the 2 volt rail, a 3.3. It needs something else to get it to enable. It's not running. Okay. It's probably related to other problems. Where is the 5 volt generator? I see a fuse marked F7005. 12 volts on one side, and on the other side, 12 volts. So I'd say that fuse is good. No voltage seems to be developed there. I don't think I have a slim board to compare to either. Got a lot of every other model board, but not the slims. I may have one somewhere. What is this right here? Nothing there. $12 volts coming in there. Is this our 5 volt supply? No. Well, it could be. But no, we had 5 volts on that one rail. I'm just checking on the USB switches over here. Looks like another one. So I'm pretty sure we don't have any 3.3. No, because that probably comes from right up here on this dialogue chip. We're missing something important here. Like we're missing what looks to be, let's look under the microscope. It looks like we're missing 5 volts into this dialogue chip. Maybe if I look under the microscope, I could tell where it comes from. Yes, there you go. It doesn't run off of 12 directly. It runs off of 5. Nothing there, nothing there, nothing there. These are going to be 3.3 and 3.3 and 1.15 down here. Kind of recognize that layout of those two big coils. And of course there is nothing there, nothing. That should be 5 volts in right there. I think that capacitor should be on the 5-volt rail. And it comes in probably over here as well. But I don't see 5 volts like we have a blown fuse, which may be on the other side of the board in this same area. Let me flip it over. We're going to look at the other side of the board in that same area. And we're going to knock our clip leads loose when we flip it over, because why not? Just a moment. Get my leads reconnected. They are still drawing 2 milliamps off the power supply, because there's a whole lot of nothing going on there. All right, here's the back of our south bridge. Another little DC-DC converter there of some kind with some thermal putty on it. I'm not seeing a fuse like I was expecting to see, because I didn't see it on the other side of the board. Give me just a moment. I'm looking at where the dialogue chip is. It is right in this area. So is there a fuse in that immediate vicinity? I'm not seeing it. What is this? Nothing there. Nothing there. Nothing there. What is under this? But I'm not seeing even 12 volts there either, though. Still think I'm missing a fuse somewhere. Somewhere there's a fuse. Let me hunt around and see if I can find this fuse. All right, I think I may have finally found something here. F7002. It's right here. I think this is, look at the mark, F7001 on the bottom. So F7001, I'm in continuity mode, is good. F7002, I do not appear to be good. So our fuse is open on F7002, and if I check continuity to ground right here, we have a dead short, 1/10 of an ohm. So wherever this feeds, we have a short to ground. I don't know where it goes, but I'm guessing it goes somewhere around that dialogue area. Let's go back to that area. Yeah, do we have we measure a short right in this area? We do. We do indeed. So most likely we have a shorted capacitor here somewhere. All right. Well, there's going to be several, caps on that 5-volt rail. All right, let's get set up to inject a little voltage. I'm just looking for a good place. Is this shorted? No, I think, yeah, that's short. That's also 5 volts over here. So it comes in over here. It comes in over here. There's a cap there. Maybe up here. Yep, up here also. So how about on this pad right here with this IC? This is something they decided they didn't need. So right about there. Anybody spotting any capacitors that look questionable? I don't yet, because there could be one on the back side of the board also. So, okay, let me get some wires. I'll get a wire connected to that point over there. Wake up the thermal camera and see if we can find this short. All right, I think I'm ready. I had to charge up my camera a little bit. I think we're ready to see if we can find this, though. I have my second channel, my power supply set for 5 volts at 2 amps. So hopefully that's enough for us to locate this. I think it will be. It's like 1/10 of an ohm short, so I'm expecting something in this area. Let me get on over in this area. Something in that area. Let's see what happens. Something in there. Is that from the other side? Must be the other side. Oh no, there's something getting warm over there, isn't there? 2 amps of current flowing. Is it just right there? I am seeing a capacitor there. Let me look at the other side right quick, like. Now that's more like it. That's more like it. That's something sure enough hot. Oh, right on this IC on the other side. Okay. Still got the thermal putty on it. Okay. Let's turn this off. And let me stop with the thermal cam. Let's look under the microscope. And maybe we can narrow it down with some alcohol. It was, yeah, we're back kind of behind the area of that DA9065. But this was getting warm. And that coil was getting warm, I think, probably because of some current going through it. So is it going to be this IC here? Or is it going to be a capacitor nearby? I'll pick some of this stuff off. Where are my tweezers? Get out of the way. All right, maybe a little cotton swab with some alcohol in the area. All right, let's give this some current now. I'm going to re-enable my supply. Ooh, was it that large capacitor right there? Possibly. Not 100% though. Yeah, it does look like it's going away rather quickly. Not too quickly though. Of course, it's only half a watt of power being dissipated. What if I turn this on up a little? Let's give it 3 amps. Yep, that's a little quicker then. Okay, let's take that cap off. Let's take that cap off. That's a large capacitor. I don't know what its value may be. I'm going to add a little leaded solder to each side of it. Let's see if it will willingly come off now. Oops. Well, let it go. There it goes. Park it right there. All right. So what if I were to give it 5 volts right now? No short. No short. I enabled it momentarily. Our short is gone. Let me get my meter in continuity mode. And this big old cap right here is very, very shorted. Okay. So it was that capacitor. See if I can go ahead and get it off of there. We'll look at it from the other side. Kind of curious if it has a crack in it anywhere. Not really seeing anything. Nothing really jumping out at me. I would not have suspected that one on looks alone. Okay. Let me see if I can figure out what to replace this with. That's a large capacitor. That probably was something like 47 microfarad or something, but okay, see if we can figure it out. Let me see if I can find a replacement. If I have another board to compare to. So we have a shorted capacitor. Unfortunately, I don't have another EDM044 to look at to try to figure out or to pull the part from, or just figure out the value of it. I don't have one. I've asked around and I haven't really gotten any solid answers on what the value of that capacitor could be. So we're going to have to get a little creative, I'm afraid. The DC-DC converter here's our capacitor that is on, is marked ORF. It's right in this area right here. And here's that capacitor. Well, according to ChatGPT, that same ORF buck converter is on an EDM033 board. So, I happen to have an EDM033 board right here. So let's just see if we can spot that. Same DC-DC converter. And I think it's right here. Let's look under the microscope. Kind of confirm this. Get it in focus. I have to tilt the board a little. Now it's hard to see. Let me see if I can get the board at just the right angle. Can you make that out? Those top letters, ORF. Yeah. So it is a 7-pin, a DFN 7 pack on this EDM33 board also. And right above it on the same pin, which I'm guessing is pin 7, depending on how they number these. This is 1, obviously. 2, 3, 4, 5, 6, 7. Has an odd number of pins. So look right here above it. 2 rather large capacitors. If I set our shorter one right beside it, look Looks very similar, doesn't it? Same size, same physical dimensions. So let's pull one of these off and see what we get. I'm guessing this is going to be 100 microfarad. That's my guess, though. So let's pull one of these off and see if that's accurate. This is the best way I've come up with of what I was hoping. Of course, I'd love to find a data sheet on this IC, this ORF buck converter, because that data sheet might tell you what they recommend, to put on the input for decoupling purposes. But without that, well, then we're just going to have to do it this way. Add a little bit of leaded solder. Let's see if we can remove this. Let me just set it to the side right now. Slide it off to one side so I can get so it can't run away on me. And I can get a measurement on it. It's on a 5-volt rail, so it's probably 6.3 volt rated, maybe 10. All right, let's let that set there for a moment. Maybe cool off a little. And we will see if we can get a measurement on it. Wake up my tweezers here. Maybe a little bit warm. Let's see what we get. I'm getting 44 microfarad. So mostly it's climbing because it's cooling off. 45. So most likely this is a 47 microfarad. Wow, I expected it to be larger. Yep, looks like a 47 microfarad. Still climbing as it cools off there. It does look to be the same. That's what we'll go with. Well, with our capacitor replaced and a new F7002, I believe it was, right down, if I can get it to focus, in there, I think we're at a point of testing this and just see if it will at least give us a good, initial 300 milliamp draw. So I've got my leads connected, hopefully correctly. So channel 1 of my supply over here, I'm going to give it 12 volts and 212 milliamps and holding and come back down. Is that normal for these boards? I really don't know. I honestly don't know. Haven't worked on but a handful of these slim boards. If I can get that to focus. 212. All right, the timing of it looks right. Just not sure about the peak current on these slim boards. So, all right, let's slide it back in the chassis. Let's see if it'll turn on. All right, it is time to see if we've done any good here. I think I've got everything hooked up that we need at the moment. Yeah, I think so. Let's find out. No beep, but the beep can be turned off. We're flashing. Nothing on the screen yet. Oh, white light. And we're doing a storage check. All right, that looks encouraging. All right, so that one shorted cap took out that, prevented that DC-DC converter from working. I did check, by the way, the capacitor, the DC-DC converter that it was on, the capacitor was on, it generated 2 volts. It generated a 2-volt supply that was needed for, I know that DA9065 gets it, several other things probably get it, but it was a 2-volt supply. That's what was missing. We are coming back to life. Yeah, that beep does work. Okay. All right, I think she's going to work. Let me do a little bit of cleanup. No, she's not too bad at all. I need to clean that fan out. It's a little dusty, but I'm going to clean it up, put it all back together, and we'll give it a good test. How's that sound? Well, this PS5 is fully reassembled and is working fine. I've installed a game. It's running just fine, no issues. And yeah, once again, a single capacitor takes down a PlayStation. All too common. Well, anyway, I hope you liked that one. I thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me that thumbs up, and I'll see you in that very next repair. Bye for now.